Okay, today we are going to learn about some important aromatic compounds, nitrobenzene and trinitrotoluene. Nitrobenzene can be obtained by the nitration of benzene in the presence of sulfuric acid. It is liquid at room temperature. It has a harmful physiological effect on the red blood cells, red corpuscles, and on the liver. Nitro is a metal-directing and deactivating group. Okay, so to do this, let me show you. First, you have benzene ring. If you have benzene ring, okay, so this combination, nitric acid HNO3 and sulfuric acid H2SO4, this combination will give you nitro group. So what do we have? If you mix them together, you get nitro group, and nitro group is going to replace one of the hydrogen on the benzene ring. Okay, you have 6 hydrogen, one will go, and in place you have nitro group NO2. Okay, so what will happen to the hydrogen? It goes with hydroxide to make water. Okay, it's kind of oxidation. Is it oxidation reduction? No, actually. Okay, so so it is a substitution reaction. It's kind of okay. So that's it. But of course you can further nitrate this. Okay, so this is why you play with the temperature actually. Okay, so otherwise multiple nitrations may happen and they are dangerous. Okay, they explode. So this way, but this product is very important because we use this to produce another important organic compound. Okay, so what do we have? We have this combination HNO3, concentrated HNO3 and sulfuric acid mixture will give you a nitro group. Okay, this nitro group will come out of this mixture and then nitration will take place. Okay, and then TNT, this trinitrotoluene, is used for military purposes as an explosive. It is obtained by the nitration of toluene. Methyl is an orthopara directing group. Okay, so this thing, you have toluene here. The key thing, you have toluene, it is methyl benzene. Okay, CH3, this is methyl benzene. And then if you use the same mixture, this concentrated nitric acid and sulfuric acid, of course we need 3 nitro groups, so this is why we're going to use 3 nitric acid molecules. Okay, and then sulfuric acid is a catalyst there, H2SO4, and nitration will take place. This is orthopara directing group. This group, they say, it means if it is there, or the near ones, these positions are going to be what? They are going to be substituted, and then if you write them, the product will be something like this. Methyl will remain there, CH3. Okay, and this position, hydrogen will go, nitro group will come. Hydrogen will go, nitro group will come. Hydrogen will go, nitro group will come, and 3 water molecules will form, of course. Okay, so this is TNT. This stuff is TNT. 3-nitrotoluene TNT. It's explosive. Okay, so especially when they build roads, okay, or in mining, they use this. This is good for us. In mining especially, they explode the big rocks with TNT so that they can grind them and then dive deeper, of course. Okay, that's it. So aniline is an oily liquid, is insoluble in water, is a basic substance, is not acidic, a basic. Okay, remember the concept. Is an amino group attached to the phenyl. It can be obtained by the reduction of nitrobenzene. Amino group is an ortho and para directing group. Aniline is poisonous. It is aniline. Okay, so reduction of nitro group will give us what? Will give us this aminobenzene, aniline. Okay, so let me show you the reaction. So you have nitro group. So if you have nitro group, so we are going to reduce this thing to what? To aniline, aminobenzene. Okay, so for this one, NH2. Okay, so to remove these 2 oxygen, we should use 4 hydrogen. Okay, so So overall it's going to be 4 hydrogen. To remove what? To remove these 2 oxygen there, these 2 oxygen atoms there. Let's say, okay, you can do like this, and then you should add 2 more hydrogen to the nitrogen. So is why 2 more hydrogen we are going to use. Okay, so overall it's going to be 6 hydrogen. Okay, 6 hydrogen. Okay, and then what will happen? You will have 2 water molecules. In each water you have 1 oxygen molecule. Okay, so the source of these hydrogen atoms is zinc in hydrochloric acid. Okay, HCl, zinc chloride will form, and then hydrogen gas will come out, or they use tin, okay, in hydrochloric acid. That's stuff. This kind of reaction there. You should be able to write this reaction. So what else? This thing, this aniline, this aminobenzene, it is base. Okay, so it gives the reactions of bases. Okay, so if you write it's going to be like this: aminobenzene. Okay, it is insoluble, NH2. If you use hydrochloric acid, okay, so it will give reaction. It will form ammonium chloride, and it's soluble, NH3Cl. Okay, it's kind of, you can put plus and minus there, like this is a salt. Okay, it's kind of, it's taking this hydrogen. Nitrogen will take hydrogen and chloride will join. Kind of, okay, you get this. You kind of get this salt. So it is base, it's a base, and this is an acid. Okay, so it's going to be acid. This is going to be salt, but no water formation. Okay, no water formation there. Okay, so ammonium chloride, what else we have? And there is a question about it actually. How many milliliters of 0.5 mole hydrochloric solution are needed to react with 2.79 grams of aniline? So once you write the reaction, you can answer the question quickly. Okay, so there, what is it? 2.79 of this thing. I find the molecular weight of aniline is 93, so divide by 93 to get the number of moles. If you get the number of moles, it's going to be 0.03. Okay, and then use mole ratio. Okay, it's 1 to 1. One molecule will give reaction with 1 molecule. So the number of moles of hydrochloric acid is going to be 0.032. Okay, and then what will happen? And then use N is equal to, concentration or molarity is equal to N over V. Here we have the number of moles is going to be 0.03. The other one is going to be 0.5, and then if you get the 0.06 liters, is going to be around 60 milliliters. Okay, it's a typical stoichiometric equation. Okay, you know it. And when it's passed through aqueous bromine solid, it produces a white precipitate. I told you, remember, this is going to be auto para directing group. I mean, near carbon atoms will get substituted. Okay, and so what will happen? Let me show it. Okay, it's like kind of nitration of toluene. Okay, so you have aniline there, so aniline. Okay, this is going to be NH2. Okay, Br2. If you take Br2, it's going to be aqueous. So what do we get? This position, ortho positions. This is going to be far away of para position. Meta position will not be. Okay, so what will happen? You get NH2, Br is a white precipitate. Okay, you can write that 3HBr, 3 plus 3HBr. Okay, so this is a white precipitate, this compound. Okay, it's a white precipitate. It's kind of a reaction of aniline, and it's very important because it is used in dye industry. Dye industry, I mean the color industry, is an intermediate compound. Okay, you use this to make different colors. Okay, especially diazonium salt. You use first you produce diazonium salt from aniline. Okay, some reactions, of course. So it's very important. It's an important chemicals in industry, color industry.